Hello, everyone. It's time to look at Lab G, which deals with wide column and uses Cassandra. So let's take a look at how we go ahead and complete this lab. All right, I'm going to need to set up Jupyter and Cassandra, which I've already done from the command line, so you won't have to watch me do that. And I need to connect to the Cassandra shell. So let me do that. Ta-da! I'm in there. Show key spaces. I think this works. It's not, it's describe. All right, there's all my different key spaces. I already have a glab key space because I was fooling around with this before. So let me get rid of that. Let me drop key space, glab, and sadly, everything I just worked on before is gone. And I got to start over again. No big deal. I'm here to do it with you. All right, let's explore this lab problem set. So this lab problem set involves reading weather forecast data from 2,000 cities worldwide every minute. So that's 288 million rows a day and 1 billion rows in a year. I don't even know if that's big enough for Cassandra, but that's too big for my feeble mind to get its head around, so good enough. I think what we'll do is let's just follow along and answer the questions bit by bit. So it says, in CQL, create a key space called glab with a replication factor of 1 and a simple replication strategy. Use that key space. Okay, so I should be able to do that. I'm going to go out here, and I'll say create key space glab with replication, simple strategy, replication factor 1. All right, and then we're going to use glab, and then we're going to describe glab. Yeah, there's nothing really going on. Okay, now let's move on and do the next question. In Spark, set up a session ready to talk to Cassandra. Okay, I'm pretty much going to copy what was in the example, which is going to look probably, let's see, I don't know. So here's the example, right? And here's the stuff. Okay, and then let me go make a new one here. I'm going to just file new notebook. Okay. And let's do that. And let's see if that gets me connected to Cassandra. Got to get the jar. It looks good. I'll run it again because I don't like to see the warnings. That seems pretty good. Looks right. Looks right to me. All right, what's next? To deal with the amount of data associated with the weather.com dataset, you decide to start with a smaller sample dataset. The dataset contains 7 days of weather information for major U.S. cities, with one row being weather information for a single city on a single day. Load the dataset located into Spark, and then use print schema to inspect the schema. Okay, these questions are pretty easy right now. So weather is Spark read JSON file. There's my file. And weather print schema. takes a while. I mean, yeah, there's only 7 days of weather for a bunch of cities, but still took a while to load. It's probably not a small file. That was easy. Thought you had a challenge for me, Mike. Let's go read the next one. All right, now it says, look at the rows of data in the sample data set. Profile the data to determine what should be used as a partition and the cluster key. Find the minimal candidate key, that is, which column or series of columns can serve as a key for each row. Please note you cannot use 2020 census, as that is a population figure and coincidentally unique. Okay, so I'm just telling you right now, that's not a row you can use. Next, prove your key works in Spark. Okay, so get a count of rows for the entire data frame. Then get a count of rows when you select your key columns using distinct, removing the duplicates. If the row counts are the same, then that's a candidate key. Aha! Learning how to find candidate keys and determine if they really are candidate keys is so important. It is a skill that we learned in IST769 data warehouse, and one that I have just carried over into this particular example. But knowing how to find candidate keys and knowing that they work as candidate keys is a critical skill that every data engineer must learn. All right, so let's see if we can find the candidate keys in that data. Let's go back to Spark. All right. So I have a city. The weather's for a city, right? So maybe city and state, because there could be 2 Syracuses. So, but there's probably not 2 Syracuse, New Yorks. These are all, these doubles are out. Anything that's a double is out. Maybe this time zone. These doubles are out. The wind direction, that's out. Wind gust, wind speed, census is out. Condition out. Date, because there's 1 weather per date, maybe. All right, so let's see what the heck we got. Print weather that count. How many rows are in this baby? There's 1,600 rows in this baby. Okay. Time to start guessing. Print weather select. Let's just do this. Select date count. Oh, let's distinct that. Different dates are there in here? Grinding. There's 8 different days in here. How many different city-state combos are there? That would be print, weather, select, city, state. Is a city-state like that? State, yeah. State, city, city-state, distinct. Count that, baby. $200. So there are 200 different cities and 8 different days. 200 times 8, last time I checked, is 1,600. Aha. Aha. No one's excited about this, so I think I found my business key. Print, weather, select. Does this work as the key of the table? Date, city. The order doesn't matter. State, distinct, count. This is the kind of stuff you got to be able to do if you're going to get in the world of data engineering. You got to be able to look at your data and figure out what makes each row unique. Okay, so there I have found the natural key / business key, however you want to think about it, for this data set. These three things in concert identify each row as being unique. So the next thing that you need to think, this, by the way, is a process in the business that we call this data profiling. You probably heard of that term before, data profiling. This is a term that we use it means understanding your data set. Okay. The problem with being a student in most of your classes in data science or data analytics or whatever, data fill in the blank major you are, is that we professors do a lot of the data profiling for you. We set the example up so that it's easy to understand and you don't have to question the fields that you see and the structure of the data and what one row means. But basically, when you data profile, you're trying to understand what is the natural business key, what does one row mean, okay, for each column attribute, what are the data dependencies? Okay, that's basically the kinds of questions that you're trying to answer when you do data profiling. You could look at the data frame itself and try to do data profiling from that. You could sit here and go weather, two pandas, and just take a look at this and try to figure out, based on eyeballing it, what constitutes uniqueness. But when push comes to shove, you can't look over 40 billion rows in a customer's table or whatever you have. So you must use code to figure out if the business key that you have tried to select is indeed the right one. So what is a NAT business key? Date, city, state. What does one row mean? Okay, one row here is obviously, it is a weather report for city, state on that date. And I'm going to do like this. I'm going to use these little curlies to represent that these are like little variables. So like weather report for New York on whatever date I'm looking at this first row. I don't know what date that is, right? For each column, what are the data dependencies, right? So New York City, this is a census. That really depends on the city, right? That's the population. That depends on the city. Clear, right? This is the city. This depends on the city and the date. Because it's not enough to say, oh, it was clear on that date. It was clear on that date in New York City. So understanding all of the data dependencies is incredibly important to understanding the data. I'll give you another example. Latitude. Does the latitude have anything to do with the weather as observed on this date? If on tomorrow, will this latitude change? Hell no. The latitude depends on the city, right? So knowing that and understanding that is so important to being good at your job, and your job is to data profile. That is to understand that data. Another one, this time zone. Is the time zone dependent on the weather as sampled on a given date? No, it's dependent on the city because it's actually dependent on the Latin long. UV index. Some of these, if you don't know, look at the way they change, right? The first 5 rows here are all New York, and these values are different. That should be an indication that it is not dependent on New York, because New York, New York, New York, New York, New York, New York. These are all different. So these are obviously samples of the UV index on each day. So they depend on New York and the date together. They're dependent on both parts of that key, not just a partial dependency. Okay, being able to do that is really important. I don't want to spend too much time on it, but I do like to just not give you the answers as I do the homework, but get you to think about what it is that you're doing. I think it's so important to understand data and be the kind of person that can confidently understand data. Like I joke all the time. I could probably build you a really awesome database that helps you with particle physics, even though I don't know jack squat about particle physics. But I know data, and I know data dependencies, and I know business rules. And that should be enough to be transparent, where I can talk to a subject matter expert and get the rest of the knowledge I need to be successful at building a solution to X, whatever X is, whatever X domain is. Okay, enough of that rant. Let's go back and see if we answered the question. That would be kind of smart. Get a count of rows, 1,600. Get a count of rows based on your keys distinct, 1,600. If the row counts are the same, candidate key, 1,600. A Cassandra row key consists of a partition key and a cluster key. For this example, use the column that will guarantee you to be storing data in increasing order over time as your cluster key. The other column or columns should be the partition key. All right. So what is our partition key going to be here? It's going to be city-state. Okay. And then the cluster key is going to be the date, because that's the one that's time-oriented. Right, so we're going to set it up so that the partition key, so this is for Cassandra. My partition key is going to be state, then city. That's probably a better way to do it, rather than city, state. New York, New York, New York, New York, Albany, Buffalo, Rochester, Syracuse. Do them in that order. And then the cluster key is going to be the date of the measurement, right? The weather sampling date. All right. Now armed with that knowledge, I bet they're going to ask me to create a table. Evil Mike is going to, okay, with your keys figured out, it's time to create your table. Okay, I can do that. It's time to create your table. Using the SQL shell, write a SQL query to create the table daily city weather. Now this is an enormous pain in the marbles to do, because it's going to be a huge table. There is a lot of columns, because if you look at the print schema, look at all these columns that I have to make in this table. So there's a couple ways that you can do this. One of the ways is you can just write your create table here. And once you get it written, you can just paste it into this command line here. You can do that. I'm actually going to cheat, and I'm going to install a Python package that lets me talk to Cassandra over Python. So it's called the Cassandra driver package. Show you how it works. I'm going to do this. I'm going to say from Cassandra driver. From Cassandra cluster, import the cluster. Then I'm going to scope that cluster with cluster. And then what's the cluster I'm going to import? Usually you give it a list of all of the nodes in the cluster. But there's only one node in my cluster. It's called Cassandra. Right? It's this variable Cassandra host. The square brackets mean a list of hosts. So normally you say Cassandra host and then host 2 and then host 3, and you give it all the hosts. I only have one host. As cluster, then what I could do is say session is cluster connect to my cluster, and then session execute some SQL. Like I can say describe key spaces. Then I can run this, and I get a mistake because I forgot to put an equal sign right there. And I get an error because no viable input for describe. I can't spell, right? What's nice about Cassandra is you can just do DESC for describe. You don't have to bother to try and spell the whole thing. Okay. Oh, I guess it doesn't like that. Oh, interesting. I wonder if it only lets me do selects and things. Let's see. Select from G demo. What do we have from G demo? We had let's go find out. I think I had one users, right? Unconfigured table users. GDemo system utilization, right? I guess I don't know any of my own tables, do I? I guess I got to go back to Cassandra here. Let's see, show tables. Can I do that? No tables. So use GDemo. Describe tables. There's a names table. There's a FudgeMart order details table. Let's try that one. I'll do names. It's shorter. See, that worked. So why can't I do a describe, though? That's weird. Describe GDemo tables. It just won't let you do a describe. Interesting. I wonder if I could do a create table. Create table GDemo test ID text primary key ID. So see if this works. Oh, that worked. Describe tables. It just doesn't let you do a describe statement. Yeah, see, there's my test. Okay, so this works. All right, so I'm going to use this because now I can do something like this. I don't know if this saved me any time. I can pass in my create table here. Create table glab. What is it? Weather. And the very last thing I'm going to do is primary key, and then I'm going to say state, city, and together I want those to be the partition key, and then after that I want to use date as the cluster key. Now I just have to put in all my columns, which I have up here. Need all these columns. I'm just going to copy them because I'm lazy and edit the snot out of them. All right. Whoop. I'm a cheater and I love it. I don't know if I can have dots in my field names or not. I have no idea. Part of me says take a guess. Part of me says just make it work the first time, right? I also don't remember what data types are available. So I'm going to have to look at my notes from the PowerPoint because I don't remember what the data types are. There's a problem with learning all these databases. Do you remember all the different data types that are available to you? Int, varchar, there's a date type. Okay. Int, varchar, there's decimal or double. Let's try some of these. So this one is going to be int, text. Text is shorter than int. I'll use that. Text is shorter than varchar. I mean, date should be, let's try date. Here's the fun part. I can't have a column called date. I just can't. It's a reserved word. So let's call this weather date. Description, that'll be a text. Dew point, that'll be a, was it float? What are the options? Is float an option? There's float. Maybe I'll just go with decimal. Latitude, decimal. This is much easier than trying to type it at the command line, right? Longitude, decimal. Moon phase, decimal. I could use double, but decimal is more precise. Percent clouds, that could be just an int. Percent humidity, that can be an int. Pressure, that could be an int. Rainfall is double, so I'll make that a decimal. And snowfall, I'm going to make that a decimal. And continuing on here, state, text, temperature. I'm going to just go right on a limb and say the decimal point's a bad idea. And these are all going to be decimal. 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 You get a decimal. You get a decimal. You get a decimal. Time zone. Text. Index. You get a decimal. Wind direction. Int. Well, I gotta get rid of all those colons, don't I? Wind gust. You get a decimal. Wind direction. Int. You get a decimal. All right, let's clean this up. No colons. All the colons got to go. That's going to just blow up in my face, right? I don't know why I left them in there. Just wasn't paying attention, I guess. And you might say, Mike, why did you give me such a long example with so many columns? Mike, why? Why did you give me a homework with all of these columns in it? Mike, why? I'll tell you why. It's wide column. The tables are supposed to be wide. The key word here is wide. W-I-D-E. What does a wide column mean? It's got a lot of columns in it. Okay, let's see if this works. I'm pretty sure it won't. Let's give it a shot. Oh, all of that, and I'm not even running the SQL. I'm running this create table. So I want to say SQL here. Syntax exception. Mismatched character N, expecting set null. Okay. So this is happening right here. And that is because you cannot have a field in any database that I know of that begins with a number like this. See that? It begins with a number. So I'm going to change this to census 2020 like that. Yeah, it seems to work in Spark just fine, but Spark is like a very unique beast. You could also backtick it if you want. I think that works. But why mess with it, right? Let's just make it census 2020. Let's see if that does it. See if that paints the little red wagon. Oh, I still got an error. Unknown definition date referenced in primary key. Ahaha. See, I changed the name of the column from date. Where was it? Now it's weather date. See that? Weather date. So I got to make sure I changed it over here to weather date. Like that. All right, let's see if this works. Oh my gosh, it worked! Let me run it again. There is already a table. I wonder if there's a like insert, create table if not exists. If not exists. I wonder if that's a thing in Cassandra. Is that a thing? Oh my gosh, that's a thing. That is a thing, and I love it. I love that it's a thing. Beautiful. Let me clean this crap show up. There, now you can see it a little better. There we go. That's all of it right there. So this is just the raw code. And then this is just me connecting to the cluster, establishing a session, and then executing some arbitrary code on that session. Yay. Now let's go verify that it worked before I get all excited. Use glab. Describe glab. Describe tables, right? Weather. Describe glab. There's my key space. There's my weather table. It's got a primary key of that. State, city, weather date. All right, now I think we're getting somewhere. I think I have answered that fifth question. With your keys figured out. Okay, it's time to create your table. Woo, that was rough. Write Spark code to save the JSON data frame into your Cassandra table. Make sure the column names are the same. Read the data back out to make sure you have the same number of rows in the data frame. You haven't lost anything. This will be further proof that your Cassandra row key is set up correctly. Provide Spark code to save the data to Cassandra, then a screenshot of the select statement and output in the CQL shell. All right, let's see if we can make this do its thing. Okay. So, my data frame that I have from before is weather up here. Weather. So let's see if I can just do that. I'm going to just go for a home run, right? Weather dot write format. And then what's the format for this? It's probably like org, Apache, Spark, SQL, Cassandra. I better check the notes. The notes are on fire. Let's check those notes. Check the show notes here. Of course, I don't have it in the notes. Why would I not? You know, that would just make too much sense. So I guess I got to go look at the example. There it is. Oh, this whole example is going to be very handy. I'm gonna take most of this. All right. And paste that in there. This will save me a little bit of time. A little bit of time and a lot of bit of headaches. So now the table I'm going to write to is known as weather, and the key space is glab. And let's cross our fingers. I'll be really surprised if this works. It didn't. Yeah, see, it doesn't know certain columns, right? The columns in weather, do not match the columns in this table. See that? So I need to convert these columns into these columns up here, right? So I'm going to take these columns here. Again, this is the really sad part of doing anything with a schema. Damn schemas. Schemas are annoying. This is why people like MongoDB. Just write the crap. Boom, done. Don't worry about it. And then I'm going to have to do that 2df, right? .df. And then in here I put in all the columns I want them to rename to. So this is how you rename all the columns. And then I gotta delimit the hell out of this. It's gonna be really annoying. Like that. And my comma. And then that. And then a comma. Then that. Oh, I'm not having a lot of fun this week. I bet you're not either. You're like Mr. Rogers. I bet you're not having fun either, neighbor. As you try to gently put quotes around all these values like this. I feel like I've got a southern drawl as Mr. Rogers. Okay. Oh, thank God for knowing keyboard shortcuts, by the way. Control delete is what I'm using to quickly delete things. Control delete. It deletes white space. Control delete. Control delete. See, it kind of pays to know the shortcuts. Wish there was one that would put quotes around something. That would be pretty sweet. If one of those, oh my gosh. If one of those existed, I'd be really happy. There probably is a keyboard shortcut that says quotify this. Quotify to end. You might be wondering, how did I skip to the end like that? Watch this. Control delete, 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 quote, control right arrow, quote, comma, control delete, 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 control, or quote, control right arrow, quote, comma, control key, delete, 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 quote, control right arrow, quote, comma, control delete, 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 delete. It's the same number of deletes every time too, which gets me kind of in a cadence of doing it correctly. It's actually not that bad once you learn the keyboard shortcuts. Learning the keyboard shortcuts is one of those little bit of time pays a lot of dividends. Definitely worth doing. Especially for an idiot like me that doesn't know how to type properly. I don't know why I didn't pause the video here. I guess because I'm giving you lots of wonderful commentary. Because I really don't see any other reason why I wouldn't have paused the video at this point. But I'm close to the end. And there we go. And And I'm going to put this in weather again. I'm going to mutate it, which is never a good idea. Let's do W equals weather 2df. And I got a mistake somewhere. Doesn't match. I wonder if it doesn't like... I don't think I have a problem. Let me just check them all. How do I not have the number of... I wonder if it's because I have all these extra spaces here. You just put it all on one big massive line and call it a day. Now it's on one massive line. See what happens now. And somehow I deleted a column. That's going to be great. Trying to figure that out. Yay, schema. All right, let me break this up a bit so that it's easier to read. And then maybe I can find... Oh, look at that. I found the comma. See? Found it already. Found my error already. Okay, that works. So I've renamed all these columns, and now I'm going to write W out. And W should now write out cleanly. Oh, I still got an error. Let's see what the error is. Job aborted. Do stage failure. Columns not found. Wind gust. Wind speed. Aha! Oh, yeah. Yeah. Yeah, so I have more editing to do, right? Because it's not wind gust decimal and wind speed decimal. It's just wind gust and wind speed. All right. Oh, finally. Okay, so that's the... I mean, this is what it is, man. But, you know, there's no easy way to do this. And unfortunately, it just sucks. So let's see if it worked. So I'm going to go over to here, and now I'm going to do select from weather. I get a whole bunch of data, right? And I guess if you want, I can do this where city equals New York and state equals New York. I'm going to use my partition key, and that didn't work. I wonder if it's New York City. Nope. I wonder if it's New York. Oh, the states are spelled out. California. I'll just use Sunnyvale, California, because it's right here. You don't want to watch me fumble over this. So, where city is Sunnyvale. State is California. Jeez. Louise with the typing. There. Okay, so boom, I get data back. It's obviously working. Now, are the row counts right? Let's load it back into Spark and find out. So W2 equals Spark read format. Just going to copy that. And I don't need a mode to load here. Then W2.count. 1,600 rows. Looks good to me. Everything's still there. Love it. And you know it's right because I set a key. And that's the only constraint in Cassandra. And what's awesome is when I have append here, it doesn't... It just rewrites the same data again and again. It's like overwrite, but it isn't because of the way that Cassandra does an upsert. Okay, end of that PSA. Let's keep moving on here. Okay, write a CQL shell query to get the condition, description, and daytime temperatures for Syracuse, New York. Include all dates. So get the condition, description, and daytime temperatures. Condition, description, and daytime temperature. condition, description, daytime temperature. Okay, I think I got it. Select city, state, weather, date. Condition, description, daytime, temp. Is it daytime temp like that? Daytime temperature day. Let's see if that works. It's not weather date. It's weather date. Weather date. Weather date. Yeah. Yeah. Weather date, Mike. W-E-A-T-H. Weather date. Okay, there we go. That's Sunnyvale, California. Now let's get Syracuse, New York. This should be easy. New York, Syracuse. There we go. And it works without allow filtering because I do not, I used the partition key, right? I used the partition key, good to go. Okay, let's see. That was easy. I love it when it's easy. A lot of this stuff, the hard part is getting the data in. Once you get the data in, it's easy. Write the same query as 7, but using Spark SQL. Register the data from Cassandra as a temp view, daily city weather, then use Spark SQL to filter on Syracuse, New York. Instead of showing the output, explain the query and show that it's being passed through. Welcome to big data country. Woohoo! We're alive with flavor. Okay, let's see if I can get this to work here. Okay, so let's do this first. Let's do W2 save as temp or create or replace temp view. And what was it called? Daily city weather. Daily city weather. Daily city weather. And then now we can do select. We can do Spark SQL query explain. And then the query I want to explain is the query I just wrote. I'm so nice to you because you just wrote it. You don't have to rewrite it or even do a different one. If you've got any copy pasta ability, you can do this. Copy. Paste. And I got to change some stuff around, but that should be easy. It's not going to be weather here. It's going to be weather city data, daily city weather. Clean this up a bit. That looks good. That'll work. Okay, and if you notice, it's passing in these filters. It's passing in these filters. Very nice. Very nice. Welcome to big data country. Cool. All right, what else did I want you to do? Your company would now like to allow users to find cities where it's raining on a specific date. Specifically, they would like to query to show the city and state name, date, condition, and description for only those cities where it's not raining on a given date. Okay, so company would like you to now show cities where it's raining on a specific date. Oh, it's raining, not raining, is raining. Where it is raining. Duh. Where it is raining on a given date. Write the query in Spark or Spark SQL. Are there going to be any Cassandra filters used? So I want to show name, date, condition, and description. So it's pretty much all the things I had before, but I don't want to filter by city anymore. I want to filter by condition, right? That's it. I just want to filter by condition. Oh, and date. Raining and then a given date. All right. So let's do this without specifying a given date. I'm going to use 2 pandas. It just looks nicer. I know it brings it to small data, but that's fine. I'm just outputting it anyway. So let's say where condition is raining. Do that. Get nothing. So I probably screwed something up. Let me just see what we got over here. I think it says condition is rain, not raining, just rain. Rain. There we go. There's all the rains. And then it says you're supposed to pick a given date. So I'm going to just pick this date. Doesn't matter. And weather date is going to be this date. There you go. These are all the cities in which it's raining on that date. Interesting. Now, the question that we posed was, what is happening here? Is this using any filters or not? So let's put that to an explain. And it's using the partition, the cluster key. It's using the cluster key, but then it's not using the condition because that's not part of a key. So this seems like a good index candidate. Putting a condition, putting an index on condition. Run the same query from 9. Obviously, it allows allow filtering. Is that true? Does it allow filtering? Do I need allow filtering? That's not copying, pasting. Copy. Oh, I can't do it that way. Let's see if I can copy this. Okay, now it's not going to work because that's not the name of the table, right? But I can, now that I got it in here, I can change this from to just say weather. Let me do that. See, it says you must put allow filtering on this. Allow filtering. And now it works. But we don't want to do this because this is cluster unfriendly. Remember, Cassandra is not made with, 10 nodes in the cluster. It's made with hundreds of nodes in the cluster. I think I'm going to start by making an index on here. Then after I make the index, maybe I'll do a materialized view. But you can certainly get by with an index here. The advantage of using the materialized view is you get to rewrite what your partition key would be. So I could repartition these instead by date and weather condition rather than by city and state. I mean, that's the only advantage of using the materialized view. They're both going to improve performance. One of them is going to also improve performance by rewriting which nodes the data is on. And remember, in Cassandra, you aren't having small clusters here. You're having very large clusters. So I'm just going to do an index for now. Condition. So making an index IX condition on whether new key is going to be condition. All right. Let's see if that index solves this problem. Might not. It does not. See, because I really needed to put both condition and weather date in as the index, right? Not just one, because they're both being used as part of the key here. So that was an inadequate index. So I'm going to drop that index. Okay, and then I am going to recreate. I guess I could show you. Let me put that index back. I mean, I got your attention, so I might as well make you learn something, right? So I'm going to put that attention back, and I need to have allow filtering on here for it to work. But what happens in Spark? So I'm over here in Spark, same query before. Does it use my index? It still doesn't. It uses the cluster key, but it doesn't use my index. By the way, if I take out this part, it will use the index. It should. It doesn't. Oh, did I drop the index? Yeah, I made the index. So does this use the index? That seems to use the index. So how come this doesn't use the index? It doesn't use the index. So it must be that maybe the Spark connector isn't smart enough to read the indexes? Yikes. That's not good. Let's see if we can verify that, right? This is, again, maybe one day it'll read the connectors, but it doesn't right now. Let's make the proper index here first. Let's go back. And let's try to drop that index. And let's make a new index on both this column here, which is weather date. Weather date. There we go. Make that index. Custom index. Create custom. Oh, okay. I don't know how to make a custom index. I guess I got to do some reading. Interesting. I've kind of hit the end of the internet. I love when this happens. You probably don't like when this happens, but welcome to the world of big data, by the way, where anything is possible and nothing is plausible. All right, let's check this out. So Cassandra, custom index. What the heck is a custom index? Create custom index. On key space table column with options. Table attached secondary index. What are the other kinds of indexes you could make? Table attached secondary index. All right, so I guess I need to put this using in here. Let's see if this works before I get all excited here. Failed to retrieve target column. Interesting. Looks like I can only use one column. Interesting. I guess I can't make a multi-column index like that. It's not supported. So it looks like I might have to try a materialized view here. I mean, it's really interesting because when I add this, let me just drop that index again. Let me make that index the way it was originally. Then let me go here and run this query again without the date on it. Works, right? Then I go back here and run this query without the date on it. Doesn't use the Cassandra filter, which implies to me it's not using the index. So the question becomes now is, can I make a materialized view to fix this? So can I... Oh, see, it says that our version of the Cassandra and Spark connector does not support materialized views. So it probably is the case that the connector doesn't support indexes either. It doesn't recognize the indexes in there. That's a bummer. So if that's the case and you're really using this, what are your options? Your options are to put another table in there, to actually store the Cassandra data in another table keyed differently. And that key might help. Like you could key it by date. You can partition key it by date first or something. But what I think is really fascinating, what is really kind of fascinating here is that it could be using the index. It's just that the way that Spark works is it doesn't show us that it's leveraging the index that we have. That could definitely be the case. It just doesn't leverage the index that we have. So a way to think about it is if I go back up here to this code that did the loading, right, which is right here, where I create this table, right? I can make a weather by date table. I flip these keys, right? So now the partition key is this way. That. So I partition by weather date, then I cluster by state and city. Okay. And I got to just fix that. Take that comma out. Okay, so that makes that second one, and then this loads into, I gotta load this into weather, what did I call it? Weather by date. Okay, and then if I go down here and say weather by date, load that other table, and then create a view out of that, a Spark view. Check out these filters. See this filter? Remember, now this daily city weather is partitioned by date. So check out what happens here. Okay, it still works because these are in the cluster key. Now the question is what happens down here? And then let me put this date back in here. What happens down here? It uses weather date, but it doesn't use condition rain. So now can I leverage the fact that I put an index on this to do that? So now I have to go back here again, and I have to add this index, but not to weather, but to weather by date, which is partitioned differently. And I got to call this IX condition by date. Okay. And let's see if that, first of all, let me go back this one here. Here's the one where I had, there we go. And let's try this from weather by date. See, that requires no filtering. No allow filtering is necessary there. Don't need it. So let's see what happens here. Okay, it still doesn't say it's using the index. It doesn't tell me that it's using the index, but I don't know. My hunch is that it's not using the index because it doesn't show me that it's using the index. But at least now it's using the partition key. So this is really interesting. So partitioning it this way actually gives me some benefits over the way I had it before, because at least now it's adapting to using one of those filters in there. Okay. But I mean, these are the kinds of experiments you sort of have to do to figure out what you have, because what's more important than anything is making sure that above all, you're passing through as much of the filters as you can to the database so that you're retrieving less of the data into your Spark cluster. This is like imperatively important. Again, I'm going to go back to the article that I sent out the other day that says Apple has 160,000 nodes that it uses for Cassandra. Imagine the size of that key space. And imagine a situation where it has to read 40,000 nodes to figure out what the data is. You're just not doing it right. You gotta leverage that partition key at all costs to minimize the amount of nodes that need to participate in selecting data from the query and selecting data back out. Again, Cassandra's designed for writes, but you can also read the data back out, but you have to read it out in a very careful way in order to avoid situations where you're gonna, make that ring be too gossipy as it tries to figure out where all the points of data that you need to bring back from the query are. All right, I answered all 10 questions. I guess this one is really kind of still up in the air. It's like, you can do it, you can't do it. Interesting. So, I tend to do this a lot in these homeworks is, I'm trying to encourage you to think, right? And so I will give you questions that don't have a real definitive answer because, like I said, the landscape of this big data stuff is so rapidly evolving. And what I'm trying to teach you through practice is heuristics, right? Yes, you play around with MongoDB. Yes, you play around with Cassandra, but what are the underlying things that are never going to change about when we distribute it, when we distribute data and then query it? What are the fundamental things that are never going to change about that we're always going to have to be concerned about? Okay. And one of the key things that we've learned so far is you want to minimize the number of data that you read, the amount of data that you read, because reading it off of a disk takes time. And number two, you want to minimize the amount of data that you're sending over the network from point A to point B, because that is slower than reading it from disk. So as long as you hold on to those two heuristics, you'll be well served in the future when, the next big database comes out that does X. So you'll always have to remember that and keep that in the back of your minds. All right, thanks for your time. Appreciate it. Hopefully you learned a lot as you went through and did the homework, and hopefully it wasn't too challenging for you. All right, a last minute addendum to the video that I just recorded is coming right now because I just figured out why it wasn't reading the index. I have to reload the data frame and recreate the temp view. And I believe this has to do with the way that the Spark connector works. There must be some caching of the metadata associated with the table and whatever indexes it has. And when I go to this screen and make an index over here, Spark doesn't know about it when I just run this query. I actually have to rebuild this guy for Spark to understand that this thing now has an index. So when I reload the data frame and recreate the temp view, and this, I think a lot of this has to do with lazy loading and delayed execution, the things that make Spark so good at what it does. When I reload this and then rerun the query after I reload it, then it has it obeys the index that I added. So I have double and triple check that, and that is the case. So that's something that that caught me off guard, and that's something that we all have to remember, is that when you make changes to the database schema, you want to make sure in Spark that you reload the data source from the data frame. And that's probably going to be the case for all the databases that we use from here on out, because again, with that delayed execution model of Spark, it's not really, it's putting a lot of things behind the scenes to get ready to read the data. And it's probably doing a lot of heavy caching, and it had no idea that there was an index on there that it even should obey. And so it didn't.